We're on 5.1, the warm-up. All three angles of a triangle add up to equal what? 180 degrees. That's the best yet. Very good. Okay, to refresh that, when I graded tests, guys, 180 degrees represents what? An angle, right? So please never tell me that the sides are equal to 180. Because sides are made up of lengths, and length can be any measurement. Okay, angles have to equal 180 on a triangle. Okay, so I noticed on your test, a lot of you had issues with, you were telling me that the side length of something equals 180, and you can't assume that. All right, so the first thing we're talking about is a perpendicular bisector. It's a line, a ray, a segment, or a plane that is perpendicular to a segment and its midpoint. All right, what's that mean? Perpendicular means what? Good, a 90-degree angle. And bisect means what? Cross each other, but more specifically, in half. Very good. So perpendicular bisector means not only does it cross or touch, but it creates a 90-degree angle. And bisect means it cuts it in half. So it's a line or some kind of ray, segment, plane that cuts something else in the middle and creates a 90-degree angle. It's kind of neat. Equidistant from 2 points means that between 2 points, it's the same distance. Okay. So that's kind of like the middle. The midpoint is equidistant to both endpoints. Let's see if we can fix that. Okay, distance from a point to a line. The distance from a point to a line is the length of the perpendicular segment from the point to that line. And equidistant from two lines, it means it's the same distance apart from each other. Okay, same distance from one line to the other line. Remember, you can't measure lines, but you can measure how far away from each other they are. The line keeps going in both directions forever. Okay, next slide. Go back. Is that okay? All right. Next one. Theorem 5.1 talks about perpendicular bisector. If a point is on the perpendicular bisector of a segment, then it is equal distance from the endpoints of that segment. Okay? So it's equal distance from the endpoints of that segment. So if I look at the picture to the right, I've got the line